Hello, Hornets. Thank you and welcome. I appreciate you joining me today. Today we're going to be talking about how we graph an amplitude of a sine and a cosine function. So we're going to start off by just taking both functions and we're going to graph one, and we're just doing the very basics. So whenever you're graphing, we're going to be graphing two periods. And when we graph two periods, what I need you to be able to do is simply break off. So let's go ahead and do y equals 3 sine of theta. Now, because of the 3, we're going to be going up 3, 1, 2, and 3, and down 3 from our center line. Now, the center line is that center of the graph, and that is represented by this vertical shift. And you'll notice the vertical shift right here is a plus 0. So we are sitting on our line where we have a height of 0. The amplitude is going to force us to go up 3 and down 3. So what we're going to want to do is we're going to want to now break this up into two periods. So I'm going to go ahead and I'm going to move over here and I'm going to call this 2 pi. Now I know this is 2 pi because the value in front of theta is a 1. And the period is always 2 pi divided by b. Just a reminder that the function we're working with is y equals a sine of theta, b parentheses theta minus c plus d. There we go. Now that's a little bit hard to see, so I'm just going to rewrite it so everybody can tell what I'm doing, and no one will be surprised. So we have the sine, and I have b. Alrighty. So our b in this is 1, and we know the period is going to have to be 2 pi divided by that b value. Now it is an absolute value. In this case, it really isn't going to matter much, but we're going to write it that way anyway. So we have 2 pi, and over on the other side, we're going to also do negative 2 pi. We're now going to divide it into fourths. Half of 2 pi is 1 pi. Half of 1 pi is pi over 2. And if I add pi over 2 plus pi, I get 3 pi over 2. Working backward, they're all going to be mirrored images. So I have a negative pi here, negative pi over 2 here, and negative 3 pi over 2. Now this is always going to be the case. Take your period, divide it in half, divide that half in half, and then add those two to get the third piece. Now we know sine starts at 0 on the center line. We know it will then have the amplitude up 3, then down 3, up. This is the general shape of our sine curve. This is one of the main things that you need to be aware of, is what that shape should look like. And it now allows me to draw my curve. So the curve goes up, and just try to make it a nice smooth curve, okay? Don't try to be perfect. You're not going to be. Just try not to make them too pointy as you go up to the top. See how it's nice and flat there? And it goes down to the 0 pi. Then we continue. And it continues up. Now, once I've got this, I'm now going to have to label all of my points. Negative 2 pi 0, negative 3 pi over 2, comma 3, negative pi, comma 0, negative pi over 2, negative 3, 0 pi 0, pi over 2, 3, pi 0, and 3 pi over 2, negative 3, and 2 pi 0. This is now the sine, or the y equals 3 sine theta. And that's my function. Notice amplitude, sitting right here, is how far up. we go from the center line, and how far down we go from the center line. And it is consistent at each extrema, be it a relative maximum or a relative minimum. Once again, we're now looking at two periods of our sine function. Let's go ahead and take a look at cosine now, shall we? Y equals, and let's now do any cosine should do, so let's go ahead and do 5 cosine theta. We could do a negative, that would just cause us to reflect through the axis, and we'd be not too much difficult, or not too much off. Maybe we'll do another one of those in just a minute. So I'm now going to break off 5. 1, 2, 3, 4, 5. 5 up, 5 down. 1, 2, 3, 4, 5. Once again, we're looking at the formula y equals a cosine of b parenthesis theta minus c plus d. Our center line is therefore plus 0. I personally like to show the center line. And when we start getting more and more complicated, we're going to want to make sure that it's clear. I'm using a different color just so that I can make it clear where it is. And sometimes it's a little bit hard to see when it overlaps our horizontal axis. We're now going to have to break up our period. We can see the period is 2 pi again. And you'll notice I always do the same thing. Don't deviate from your process. If you do, it's going to become more difficult. Why make life difficult for yourself? I'm just going to put in all of my radian values going around. If you wish, you can always go further. We know that it'll be 5 pi over 2. And we can go back even further if we wanted negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and negative 5 pi over 2. Once again, this is 2, then 4, up to 5, negative 2, negative 4, and down to negative 5. Now, believe it or not, we're ready to begin. Cosine always starts at a maximum. If I had a negative in front, it would start at a minimum. So I'm going to start right up here at that positive 5. Then I'm going to go to 0, then drop to negative 5, back to 0, up to positive 5, and back to 0 again. Going in the other direction, 0, negative 5, back to 0, positive 5, back to 0. Let's make sure I've got that, and back to 0, yes. I now have my points. I'm going to draw my curve. Notice it's just making it elongated. It's stretching it. So the amplitude is going to stretch our graph. Once again, don't try to be perfect, although it helps to try not to be too sloppy either, right? I'm just cleaning this up because it was too sloppy, and I know that my teacher, Mr. Lamb, would not like that. There we go. It's not perfect, doesn't have to be, but I don't want it to be pointy. Now we're looking at more than 2 periods here. Let's see, we're now going to have to plot our points. So the points that we have are negative 5 pi over 2 comma 0, negative 2 pi comma 5, negative 3 pi over 2 comma 0, negative pi comma negative 5, negative pi over 2 comma 0. Then we have 0 pi comma 5, pi over 2 comma 0, pi comma negative 5, 3 pi over 2 comma 0, 2 pi, comma 5, and 5 pi over 2, comma 0. And this is y equals the 5 cosine of theta. I'm just going to go ahead and clean up this graph just a little bit more, and we're all set. Thank you very much, Hornets. I hope this worked for you. Please be well and take care, and I hope this works. Please click like if you like it. Thank you. Be well and take care. Cheers, Hornets.